Hi, good morning everyone. Just want to welcome everyone to Fit 5136 again. My name is Clark Thantitham Thawan, so I'm the CE and the lecturer for this unit as well. And today is now week 4 and the topic will be about the software design and modeling. Today, the topics that we will cover today, it will be a lot. It has 6 topics as you can see in the slide. We will talk about what is the UML diagrams, what is the use case scenarios, use case diagram, what are the difference between objects and classes, and what is the class diagram and the sequence diagram. These are the topics that you will learn, and it will be part of the assessment tool as well. Okay. But before we start, we just so this is the high-level Agile project, Scrum project management. Again, software design and modeling. Normally, it is part of the activity during the requirement engineering. In the past few weeks, you have elicited the requirement already as a product owner, right? You elicit the requirement, you analyze the requirement. This is the functional. This is a non-functional requirement. You have create the user story with the template as something as a student I want to something and then so that something, right? So once you know what is the purpose of that user story, now you need to design the software, right? Because software is getting bigger and bigger and larger, how can we software design and modeling is one of the techniques to abstract everything into a modeling language. All right. So that will be part of the module 2, the requirement engineering. Yeah, but let's try to understand the rationale behind what is the purpose of doing the software design and modeling. Okay, so why do we need to model the software, right? Think about the Windows XP. You probably, a few of you have used it before. It has like over 40 million lines of code, so it is really large and complex, right, nowadays. And right now, you may also experience or use other kind of operating system as well. Think about the Android operating system, Linux operating system, that kind of thing. It is really large and complex. And then when every years you have or every days you have a new requirement feed into the product roadmap, right? So everything becomes larger and complex. You need to connect with the external APIs and things like that. Then how can a single programmer or software developer understand the whole project or the code base or its entirety, right? So it is really difficult. And just in real world software development projects, right? People come and go. When you have a newcomer come to the project, right? How can that newcomer understand the whole project as well? It is not easy at all. So because most of the time, code is written by some other developers, but a new person, a new software engineer join the project, right? They have to understand the whole system in order to extend or maintain the project, right? Or the software development system. Yeah, so it's not easy at all. That's why we need to have software design and modeling subject here to help project managers, help the stakeholder, help software engineer, software architect understand the high level abstract of the whole system. And when we talk about the software design, it's not about the UX or UI design. It's about the technical structure of the software system, how each of the functions interact with each other. All right, it's not about the UX UI design at all. People often have a misconception around this, but that's not true. Software design, we talk about the technical design of the software system, not just the UX UI. Okay. And once you design the software system, you understand the whole structure. You don't need to even read the code at all. You just look at the visual modeling language here, right? Okay. But the purpose of the software design, it is used to describe what the system must do, okay, and to how the system will do it as well. So it will capture that kind of requirement. What classes will we need to implement a system that meet our requirement? There are lots of things, lots of requirement. What are the classes in the system? What are the attributes? What are the data? You have worked on the the last week, the system student enrollment system. We talk about what are the data attributes that we need to capture in the class as well, the student class. So That's the thing, right? Because the text is very hard to understand. When we draw the visual diagrams, everything will be much easier to understand. So that's why we need the software design and modeling. When we design and modeling, right, normally we use the UML language, okay? So UML is it is a standard language for specifying, visualizing, and constructing and documenting the artifacts of the software system, and which can be used for the business modeling as well. This is the on the right hand side. As you can see, this is the high level structure of the UML diagram, the framework. Basically, it consists of two types of the diagram: the structural diagrams and the behavioral diagrams. Structural, think about the structure of the software system, how the class are interact with each other, okay? How the objects are interact with each other, what are their relationship. The class can be think about a user class or the student class, that kind of thing. And we can talk about the product class as well, right? An end user can purchase multiple products, that kind of thing. That's one has many relationship, that kind of thing. And when we talk about the behavioral diagrams, you just think about the behavior. What is the behavior of the software system? It is normally we use for each of the use case. Let's say the one of the use case, what is that? The purchase a product. Okay, purchase a product. What is the interaction? What is the behavior of the software system that it will interact or it will react to the end users, that kind of thing. So that's the behavioral part. Anything that looks like an activity, it will be considered as a behavioral diagrams. Something that looks like a structure of the software system, the class, the data, attribute, the object, the package, that kind of thing, that's called structural diagrams. Okay, so keep in mind UML. There are two types of the UML diagrams: structural diagrams and the behavioral diagrams. In this lecture, because as you can see in this figure, right, there are multiple types of the diagrams, but we cannot cover everything. Within this unit, we're going to cover only 3 of them: use case diagram, class diagram, and the sequence diagram. And these 3 diagrams will be used as part of the assessment tool. Okay, all right. So let's go through one by one. All right. The first one is the use case diagram. Basically, the use case diagram, it will summarize the details of the system users, your system users, and their interactions with the system. That means use case, how does user use the system? Easy like that. Okay. As you can see in the in this figure, right? You will see customer, you will see service authentication, identity, provider, credit payment service, PayPal. These are the actors of the system, and the whole use case is called online shopping system, right? That's the boundary of the system. The circle indicate the use case. There are 4 use cases here. First, view item. Second, make purchase. Third, complete checkout. And the fourth one, login. Okay, these are the use case diagram. Okay, this is an example. I will go through into details later. This is a class diagram. Basically, it shows how the object classes in the system and the association between the classes as well. Think about the data modeling as well. But this is the class, the object. Probably this is for the online banking system. You have the bank class, you have the customer, you have the account, you have the ATM transactions, you have different types of the account, the current account and the saving account. Okay, the notation, the symbols, we will talk about that later as well. But this is one of the examples of the class diagram. Okay. Previously, we talk about the use case diagram. This is class diagram, and the next one, what is that? That's the activity, behavioral diagram, right? One type of them. So this one is called sequence diagram. It will create, it is the purpose of this diagram is to visualize the interactions between the objects at the time sequence. Okay, time sequence, that's a key point here. That means when an end user want to use a system, what is the first step, okay, that they need to do? That's a time sequence. First, login. Second, buy create a username and a password. Create an account using the username and the password. Third, they can purchase something. The fourth, they can make a payment and check out, that kind of thing. That's a time sequence, you know. But the previous diagram, use case and the class diagram, there's no time sequence at all. Okay, it only describes the structure of the whole system, the structure of the software system. Okay, yep, this is the state machine diagram, and it tells you the state of the system, right? Let's say this is a washing machine. It operates as a state, right? First, we start from the washing, rinsing, spinning, that kind of thing. Yeah. So that's the state of the system. Okay. But it doesn't tell the interaction between the end users and the system, which is different from the sequence diagram here. Okay. All right, activity diagram. I think I am missing something. I skipped this one. Activity diagram it is similar to the sequence diagram, but it doesn't tell in the it's not in the time order. Okay, activity diagram is more like a workflow. Okay, first we receive an order, and then we need to fill an order, send an invoice. Once we fill an order, we can arrange an overnight delivery, arrange regular delivery, that kind of thing. When after we send an invoice, we can receive the payment. That's more like a workflow, you know? Workflow, the flow of the system, the flow of the activity, how it works one by one, okay? Yeah. But it is different from the time sequence at all, okay? The sequence diagram, it tells you the interaction between the object in the time order, okay? All right. That's a state machine, okay? And this is the general use case of the UML diagrams. Why do we need to use it, right? Because we want to use as a sketch. We want to communicate different aspects of the system. It can be the forward design, the backward design, the whiteboard. And normally in the past, we can use the whiteboard or paper to draw the UML diagrams. But we are in the 2024 already, so we need to use some the tool support, right? And the tool that we are going to use in this unit is called Lucidchart. Yeah, that's a use case of the UML diagrams. Before I go into details of the use case diagram, does anyone have any questions so far? So I'm gonna look into the Zoom chat. Anyone? If not, then I will continue. All right. Okay. Use case diagram. The first diagram of the today lecture. All right. When you read the requirement text in the student enrollment system in the previous apply workshop, right? You see that there are lots of use case in the system, okay? That's why we need to draw the use case diagram, because the text is very hard to read. It is very hard to understand. There's a higher chance that you may miss some of the use case as well, right? And the purpose of the use case diagram is to summarize what are the total numbers of the what are the use case in the software system, okay? And you define the boundary, that kind of thing. So use case diagram is a set of the multiple use cases, okay? What diagram capture multiple use cases, okay? And the use case is a model of the interaction between the external users and the software product itself. That means when you develop a piece of software system, you have the end users. Who are the end users? Who are the stakeholders? Who are the actors that actually interact with the software system that we are going to develop here, okay? Let's think about Moodle LMS, okay? Moodle LMS, there are multiple use cases, okay? There are multiple actors here. For example, the student, the faculty member, the Monash Connect people, the IT e-solution, that kind of thing. There are multiple use cases who use the Moodle LMS, right? So this is one of the example, okay? And let's take a look at the notation here. What does it mean, okay? We're gonna see one by one, okay? Actors, okay? First, the actors, let me see if I can get some annotation here. Yep, okay. First, when you see the person picture like this, it's called actor. And it is who are the users that play, that interact with the system, okay? And in this system, it's called library system. This is how to read. First, this is a library system, probably borrow a book, that kind of thing. And you define the boundary here, okay? This is the boundary of the library system. For this system, there are three actors. First, the client, the employee, and the supervisor, probably librarian, okay? And with these three actors here, there are three use cases. You're gonna draw the use case with the rectangle diagram here. No, sorry, the circle, okay? The circle here. Borrow, you have borrow use case, you have the order title use case, and the file remittance use case, okay? This is an example. All right, clear. Yep, use case, that's the notation. And next, yeah, sometimes you need to describe the include or the extend relationship as well. What does it mean by include? Include is the dot line, okay? Let's take a look at this one. Yeah, slowly, yep. This is the dot line, okay? Or the dash line is the same. Either one is okay, yeah? And you put the label include like this, okay, to describe the include relationship. And the purpose of the include relationship is that as you can see here, the include relationship occurs when a chunk of behaviors is similar across more than one use case, and we need to use include instead of copying the description of that behavior. Include means is like a dependent use case, you know, and the extend is like the optional, okay? Just an extra one may add behavior to the base use case. I'm gonna explain a little bit more in the next slide, I'm pretty sure. Include is like, it's mandatory. After this use case is done, it will include another use case. Extend is like optional, okay? Yeah, this is a better example here, okay? What is this system? We have a passenger. They can purchase multiple cards, purchase a single ticket, collect money. They can no change, probably no money exchange, that kind of thing, or they can cancel. Okay, so include relationship represent the behavior of that is factor out of the use case. Behavior is factor. I think just keep my explanation, okay? Include relationship, it's about something that is dependent, it is mandatory, it has to have that, okay? For example here, passenger, first, this is a passenger, they can purchase multiple cards or purchase single ticket, right? They cannot purchase without paying the money. That's why collect money, we describe as an include relationship. Does it make sense? But to collect the money, it has to happen after they purchase the multiple card or the single ticket. It cannot be earlier, okay? After they collect the money, when we use extend, it is an optional now, right? So they can cancel the transaction or they can no change, no coin change to the passenger, okay? That's why they use extend here. Make sense? Okay, yep. That's the include. And what about the extend, right? Extend. Let me get the draw again. Yep, we have the passenger here. First, they have to purchase the ticket, okay? That's the next step. No, so not the next step, sorry. The first use case of the passenger, all right? Once they purchase the ticket, these are the 4 options that they can do, okay? The four optional use case, I would say like that, okay? First, the machine can be out of order, okay? They can cancel the ticket purchase, okay? Or no change at all, or the system is timeout, okay? That kind of thing. So that's the extend use case. It is optional, it's not mandatory, okay? That's the extend relationship. And to draw the use case diagram, okay, the first thing that you need to do is to identify the actors. Who are the actors of the software system? And if you look at the student enrollment system, you may see you just identify the nouns, right? Who use the system? The student, the admin, that kind of thing, okay? This is the noun, the actors of the use case. And once you identify the actors, then you need to identify the verb. What is the use case here? The verb. What functions will the actor want from the system, right? Or does the system store in any information? What is the verb? Once you identify the verb, then you can identify the boundary and draw the use case diagram. Okay, let's try to do it one by one together. Okay. This is an example. This is a train ticket system. First, identify the noun. Second, identify the verb. Third, draw the boundary of the system. Fourth, draw the use case. Okay. All right. Now, identify the noun together. A customer, this is a noun, the first actor. Okay. Can purchase, this is a verb. They can purchase a train ticket. The payment can be made via the EPOS, okay, which will be authorized by the EPOS system. This is another actor as well, the third party actor. Once the ticket is purchased, the customer can print the ticket details. So this is a kind of dependency, right? So that means once the ticket is purchased, this is the main use case, okay, the main use case. Then they can print. That's another verb, okay. But this one, print here, I would say that it is optional. They can opt to print the ticket or not printing the ticket as well, right? So this should be the extent, okay. Yeah. A customer, again, the same actor can modify. That's another use case now. The date and time. This is the data stored in this object anyway. Of the purchase ticket and cancel. This is another verb, another use case. Cancel the train ticket. However, the cancellation request must be approved by the staff. Okay, that's another actor now. We need a staff to approve the cancellation request. The EPOS will make a refund. That's another, what is that? Another use case or not, okay? Will make a refund to the original payment method for the cancel ticket. Okay, so refund is part of the cancellation request, okay? So maybe we need it or we don't need it, depends. All right. Now we know, okay, who are the actors, okay? First, the customer, so it's the passenger. Yeah, sorry for the typo. Yeah, we have the passenger here or customer. All right, customer is the first actor here, and we have another actor, the staff. Okay, we have two actors now, but let's read from the top again. A customer can purchase, then you draw the use case here. Purchase the train ticket, right? The payment can be made only via the EPOS system. So that means the payment use case here, the purchase here, right? Purchase use case has to interact with the EPOS system, which is the external party. Okay, the EPOS. Once the ticket is purchased, the customer can print the ticket. As I mentioned before, print the ticket details is the extend use case. It is optional. They can print or they cannot print as well. But it has to happen after the ticket is purchased. Okay, so that's why it will be the another use case here with the extend relationship. Okay, a customer can also modify the date and time. That's the second use case here. Okay, yep, the second main use case. Modify the date and time of the purchase ticket, or they can cancel the train ticket as well. Okay, the train ticket, a customer can modify, right? So that's why we draw this one. But to cancel the train ticket, it must be approved by the staff. Okay, so that's why we draw the staff line here. Okay, to interact with the cancel train ticket. And the EPOS will make a refund to the original payment method for the cancel ticket. So when we cancel the train ticket, it has to interact with the EPOS system as well. So that's why we draw another line here. Okay, and then why we draw this one? So the first question is that, can we cancel the train ticket without purchase it or modify it or not? Probably no, right? So they said a customer can modify the date and time or cancel. So as part of the modified train ticket, they can cancel as well when they modify the date and time, or they can cancel the train ticket. So that's why we use the include relationship here. Okay, any questions with this diagram? Yeah, that's a good point. So that's a good point whether this one should be extend or not, right? Yeah. Okay, maybe I will explain the difference between include and the extend again. Okay, so first of all, the arrow will be different. Okay, first of all, the arrow will be different as well. Let me put this way. Draw. Okay, first the difference between include and the extend. Okay, include, it means that it is the use case that will happen after the main use case. Like this one, modify and the cancel here. The cancel train ticket will be the use case that is dependent on the modified train ticket. Okay, it cannot be canceled alone, that kind of thing. And the arrow is point outwards. Okay, from the main use case. Differently, okay, for the extend use case, it means that the extend use case here, the print ticket is optional. Okay, it's not mandatory at all, and the arrow is point inwards, point towards the main use case. Okay, so it is different in include and the extend. Okay, I'll try to check the questions in the Zoom chat one by one. Yep. Why does the extend arrow point to the purchase train ticket? Okay. So yeah, as I mentioned before, this is the language defined by the UML diagram. So I'm not really sure why is that. But for the extend, the arrow will be point towards the main use case. Differently, for the include, it is point outwards. Okay. Yep. So in summary, extend means an optional relationship. Yes, whereas include is mandatory. Yes, you're right. Yep. Thank you. Okay. Yeah, so I think let's go back to this one, right? I'm thinking at the moment whether this one can be extend or not. Based on the text, right? It is or. I would think so that probably this one can be extend as well. Yeah, it can be as well. It's not really clear whether it will happen after the modify or not, right? So yeah, they don't have to cancel the ticket. Yes, that's right. I agree. So probably this one, it must be extend. Yeah, I think. Yeah. Okay, thank you. So next, this is a much complex system. Okay. Yeah. This is the online clothing website. Okay. We have lots of things, include extend relationship. We have supporting actor, primary actors, whatsoever. But let's try to read the requirement text together. We have the customer. Sorry. Draw. Okay. We have the customer. That's the actor, primary actor. Okay. Now can search. Okay. This is the use case for clothing products from an inventory management system. Probably this is the supporting actor. Okay. A customer can also view individual products that are available in the inventory management system. Okay. Actually, I should read and start drawing together. Okay. We have the customer. We draw the customer here as a primary actor. They can search for clothing product. Okay. So that's the first use case. From an inventory management system. This is the supporting actor. Okay. External of the system. A customer can view, okay, that's another actor. The same actor, but another use case can view individual products that are available in the inventory system. Okay, view product, and we draw this one, all right. Okay, yep. A customer now can manage verb, a card as part of their shopping experience. Okay, manage the cart. Okay, yep. And it doesn't need to be interact with the inventory management system anyway. A customer can check out. That's another use case here. Okay, check out the items in their cart. Okay, during the checkout, when a user has confirmed their order, they will be able to submit shipping and payment details, which connected to an external payment service. Okay, so what they need to do? Shipping and payment. Yep, I move this one here. Okay, draw. Yep. During the checkout, when a user has confirmed their order, this is a checkout. They can submit shipping and payment system. That's the next step, mandatory step, right? They need to do. That's why we use the include relationship and we use the dash line. Okay, point outwards the main use case. Okay, shipping and payment details, which connected to an external payment service here. Okay, payment service here. All right. A customer can also buy a product directly with our part. Pay now, Amazon Pay now. Okay. Yep. Buy now. All right. When viewing an individual product, a customer can select buy now to proceed to confirming their order of the item. After confirmation, they will be required to submit the shipping and payment details. Yes, again, this is the mandatory step. After they press the button buy now, they need to provide the shipping and the payment details here. Okay, all good. A customer can submit, the next one, a customer can submit shipping and payment details to complete an order. A customer is required to enter shipping details and payment details that are verified by a third-party payment service. That's why we draw this line here. Okay. Extension. Oh, that's too obvious. A new advanced search feature will be added to the website in the future. Will be added to the website in the future. So it is optional. Right now we don't have it. That's the extend relationship. Okay. And the advanced search use case here is point towards the main use case when during the search product. That's the advanced search. Okay, this feature will allow customers to include additional parameters when searching for products. Okay, that's the data attribute of this class for whatsoever. Okay, make sense everyone for the example 2. Any questions? Any questions? What does it mean? Can we say confirming is a use case? Okay. You mean buy now to proceed to confirming the order of the item? Probably it is too detailed, right? I would say that the main action is the buy now, but the confirming that kind of thing could be part of the sequence diagram that you may need to draw it later. Okay, but I would not say that confirm that kind of thing is the main use case. Okay, thank you for your question. Very good. I'm gonna move on to the next one, right? So when we draw the use case diagram, it consists of multiple use case here. We have advanced search product, view products, manage cart, checkout cart, buy now, shipping and payment, that kind of thing. But for each of the use case, there will be a use case scenario as well, which will describe how things will interact with each other. Okay. So what is the use case scenario? It is a sequence of actions that illustrate behavior. A scenario may be used to illustrate an interaction or the execution of the use case instance. Scenarios are used as a scenario-based requirement elicitation, a technique of asking questions related to a descriptive story in order to ascertain the desired requirement. Okay. Let's say on the right-hand side here, on the left-hand side, this is the requirement text. The purchase, modify, cancel the train ticket, whatsoever. We already draw, okay? Given this requirement text, we already draw the use case diagram. There are multiple use cases here. For example, purchase, modify, cancel, train ticket, whatsoever. And each of the use case here, it will consist of the use case diagram, the class diagram, and the sequence diagram. The use case scenario will explain for each of the use case what is the flow of the event to purchase a train ticket. What is the flow of the event? What they need to do first, log into the system or not? How can they browse? How can they search for the train ticket? How can they purchase it? That kind of thing. Okay? And given that use case, what is the class diagram? We have the train ticket diagram. We have the customer diagram. How do they interact with each other? Sequence diagram tells you how the purchase diagram will perform in a sequence, whether it has to interact with the third-party payment system, that kind of thing or not. Okay, that's why use case diagram is the larger, is more of the higher overview rather than the use case scenario, the class diagram, and the sequence diagram. Okay. The elements of the use case scenarios, right? So as I mentioned before, one more thing that I forget to mention. Scenarios are used as a scenario-based requirement elicitation as well. So this is a very good key point. What I mean is that when you elicit the requirement, you may, the requirement text, this is a high-level requirement that you capture from the clients, right? For the train ticket system, the client want to have like a purchase train ticket whatsoever. But what is the flow of the event of the purchase train ticket? It's not known. So you need to elicit further as well. So that's why it's called scenario-based requirement elicitation. Okay, the key component, the key elements of the use case scenario. Okay, we just follow the Martin Fowler book here, 2000. And it consists of here, okay? First, the use case. What is the name of the use case? A scenario describes what is the description of the use case. We need to indicate whether this scenario, the use case scenario, is the main or the alternative scenario, okay? The main scenario is a set of interactions between the user and the system that correspond to the way we understand how the system should be used towards the goal. The main goal, we have the main goal. Let's say purchase a train ticket. This is the main scenario. What could be the alternative scenario? Think about the exception handling in Java. Alternative scenarios could be, what if the main scenario is the purchase train ticket, right? The alternative can be sold out. Okay, sold out. The ticket is sold out. This is the alternative scenario. It is still related, but it is alternative. It is an exception handling. Okay, so it is something extra. It is alternative. It's not the main use case. The main is we want to purchase the train ticket. What if the train ticket is sold out? Then we need to have another alternative scenarios. Probably the system will show a pop-up message that, okay, the ticket is sold out whatsoever. We cannot provide another blah, blah, blah. Please put an email address. We will follow up in the next X day. That kind of thing. That's the alternative scenarios, okay? This is a template, general template. We need to write what is a use case, purchase the train ticket. Scenario, we need to describe what is a scenario. Who will trigger this user scenario? The actor who performs certain actions to trigger this use case, who trigger it, right? You can provide a brief description of this use case scenario as well. Who are the actors? Okay. Are there any related use cases or not? Are there any preconditions, post conditions? What is the flow of the event? This is the main thing, okay? That we need to write as part of the use case scenario. What is the flow of the event? What if there's an exception conditions, right? A list of alternatives to the main flow. For example, ticket is sold out, the system is failure, we run out of power outage or whatsoever. Okay, that's the alternative or use case. Okay, let's try to analyze this one. Let's try to write the use case scenario together. Okay, this is the same requirement text here. A purchase can purchase a train ticket whatsoever. Okay. Then for this use case, we're gonna call it purchase, modify, cancel train ticket. Alright, that's the name of the use case. The scenario is that a customer wants to purchase a train ticket, modify the date and time of the ticket, and cancel the ticket if necessary. Okay. when this use case will be triggered when the customer access the train ticket booking system, okay, and then this use case will be triggered. What is a brief description of this use case? Simply, this use case describes the process of customer purchasing blah 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 blah. This is something just a summary of the requirement text here, right? For this use case, who are the actors? Okay, it's kind of like drawing the use case diagram, but we're gonna write in the text here. The actors here, it includes customer, the train ticket booking system, and the airport system. These are the main actors of the requirement text. Let's see if it is correct or not. Okay, we have the customer here. We have, of course, we need to have the train ticket booking system. Okay, that's the main actor, and we also have the airport. Probably something that is missing could be the staff as well, I would say. If the staff need to approve the cancellation request, yes, that's right. So probably staff should be here as well, the main actors, okay? Not the main, yeah, the main actors, yeah. Okay, then we need to discuss about the flow of the event, how it will perform, right? Think about the customer purchase a train ticket. First, the customer select a train, the date and time for the journey. Okay, we want to travel from Melbourne to Sydney. Okay, that's a train. For the next Monday around 1 p.m. whatsoever. The system calculates the total fare and prompts to the customer to make the payment. Yeah. So once we input what is the route, the journey, the date and the time, the destination whatsoever, they will tell you the price, the fare. Let's say $100, and then the customer will select airport as a payment system. The system will redirect the customer to the airport system for payment authorization. The airport system authorize the payment. The system generates a ticket with the unique ticket ID and display the ticket details to the customer. The customer print the ticket details. Probably this is a very good good use case scenario, and later on you can use this one to draw the sequence diagram easily, because it tells you which actor interact with another actor, that kind of thing. How each of the objects in the class or actors in the system interact with each other. Okay. Exception condition. This is an example. Okay. For example, payment authorization failure. When you want to purchase the ticket, but if the payment authorization is failed, what the system should do. So you can say that, hey, look, if the airport system fails to authorize the payment, the system will display an error message and prompts the customer to try again or use different payment method. Okay. This is an example of the exception conditions. Okay, that's how we write the use case scenario. Any questions? Yeah. Any questions so far? Nope. I'm gonna move to the next topic. Once we draw the use case diagram, we write the use case scenario for each of the use case, and then now we can draw the class diagram as well, how each of the objects will interact with each other. Okay, and for the train ticket system, probably as you can imagine, you may have different objects here: the customer, the ticket, the payment system, whatsoever, right? Okay, what is a class diagram? So class diagram represents the structure of the software system, and we normally use when develop the OO system. Okay, we're gonna use the OO system, object-oriented programming language. Okay, to show how each of the classes in the system are associated or interact with each other. We're gonna talk about the association, the multiplicity in the next few slides as well. Yep, and we can use the class diagram during the requirement analysis to model the domain problem, the domain concept as well. This is the domain, this is the class, that kind of thing. Okay, and you can, when you define when you draw or design the class diagram, we normally focus on the nouns again, similar to the actors. How do we decide the classes? Okay, now we need to talk about the elements in the class diagram. Okay, First, we draw the square like this with the 3 rows. Yep. This is the 3 rows. The first row, okay, we normally use to describe what is the name of the class. And the second row we use to describe attributes of the class as well. The attribute can be the data that is stored as part of this class, and the operation as well. That's for the third row. Okay. And in front of this, we can describe what is the class signature as well. What is the data type? This is the data type. Table data type, or the enumeration, or the price object, or whatsoever. Okay. To design the class diagram, normally we need to identify what are the nouns again, which the nouns can be classes, object, or fields, right? And the verbs normally we will consider as the operation or the methods, okay, of that class. Okay, a class normally represent a concept. Just a concept is not the real thing. There is a difference between the class and the object. Okay, class is the concept, the abstraction, the template. The object is the real thing. All right. Okay, and then we'll talk about the attribute and the operation later as well, and the inheritance, that kind of thing. Okay, what kind of things are considered as an object? Objects are derived from the following source here. For example, something that is tangible, real world things, the book, the notepad, the brochure. This is the real thing. Whenever it is the real thing, it's called an object. If I have a dog which is called Tom, okay, sorry, Tom, that's the object, okay, but the class, the abstraction, we call it a dog. Okay, yep. So this is an example. Rain, okay, rain, this is the object, this is a dog, okay, the object is called Rain. That is his name. It has property values as follow. First, the color is gray, white, and black. There's a blue and brown eye color. That's the height. That's the length. That's the weight. This is the property values, the data attribute. What they can do, they can sit, they can lay down, they can shake, they can come. Okay, this is the operations or the methods that is performed by the object. Okay, this is a high-level structure. One object consists of property values and the method, or the data attributes, or the operations. They are the same thing. Okay. That's a key point. But Rain, which is a dog, we can have multiple dogs as well. What if another dog that is named something else? Okay, that's why we need to create the template structure of the class, which is called dog. Okay, that's the base class. So when an object, when we create an instance here, create an object called Rain, which is inherit from the base class dog, the properties and the methods will be the same. It shares some similar properties, share some common behavior, share some common relationship to each other. Okay, so it has a color, eye color, height, length, weight. They are the same. It can do the same method as well. Sit, lay down, shake, come. Okay, yeah, that's a class. As I mentioned to you before, a class has data attribute and the operation. Okay, that's the two key point here. And we draw using these three rows of the tables here, 3 compartments here. First, the first row is the class name. The second one is the attributes or the properties of the class. And the last row is the operations and the method. All right. Okay. When we draw the class, it doesn't mean that we need to include all of the information. Sometimes we can have only the class name. Okay, this is mandatory. The rest is optional. Sometimes we can have the class name and the data attribute. Sometimes we can have the class name and the operation or the method here without the data attribute. Or we can have everything. Okay, so it doesn't need to always have the attribute and the operation in every diagram. Okay, but I mean this is in general, right? But during the assessment you have to include it. Okay. Yep. Okay. All right. Next. Yeah. So the element of the UML class diagram, as I mentioned to you before, there's a class, attribute, operation, relationship, association, and the constraint rules. We have already talked about basic component, again, why the slides are redundant here. We have the upper section, middle section, bottom section, as I mentioned to you before. Okay, this is the next one, modifiers, right? Each of the data attribute or the operations, you have to include the modifiers as well. And normally it can be as follow here. First, public, private, protected, or package. Public, it means that this kind of data attributes or the operations can be accessed by any class. Private, it means that it cannot be accessed by any other class at all. Okay. Protected, it means that it can be only accessed by the same class or the subclass. Okay. Package, I think we don't need to mention about it. It's too complicated. We don't need to cover it. Okay, so that's a public, private, and the protected. This is the three things that you need to remember. All right, and next I think I will have a few more examples in the next few slides as well. But let me try to explain all of the notation. Okay, once you know the modifiers here, then you need to know the relationship as well. For the class diagram, there are two types of the relationship, whether it is relationship or it's called association or aggregation. Okay, relationship means that one has many or more, that kind of thing. That's a relationship. Okay, but when we talk about the aggregation, it is we talk about the ownership. It is part of that kind of thing. Let's take a look at this figure. Right, owners feed pets. Please owner. This is the relationship that one owner can have many pets, but one pet can have only one owner, that kind of thing. Okay, but when we talk about the composition, aggregation, composition, it means that something can be part of something. Okay, a tail is part of both dogs and the cat. Okay, this is the aggregation relationship. A cat is a kind of pet. That's a class inheritance or generalization or the abstraction. This is an example. Let me bidirectional association. Oh yeah. So as I mentioned to you before, there are three types of the relationship here: association, aggregation, and the composition. Let's start with the first one, association. There are two types of the association: bidirectional or the unidirectional. Where's that? Yeah, unidirectional here. Okay, let's start with the first one, bidirectional. It describes the default relationship between two classes. Okay, both classes are aware of each other and their relationship with the other. This association is represented by a straight line between the two classes, and then you indicate the relationship here. Okay, whether it is going to be one has many, one has one has one has many, many has one, or many has many. Like this one. For this one, we have a car. Okay, that's the first class. We have this is a data attribute here with the public modifier. It has model type like Honda Civic. Okay, doors, 4 doors. Automaker, that's a Honda. Okay, the data type is the string, integer, and the string. The car has 3 operations here: turn on the radio, windshield wiper, or change the direction. Okay, and each car also have a road trip as well. Okay, road trip. During the road trip, you can have a snack. Yeah. Okay. Fuel level. Whether the fuel level is full or not enough, right, or empty. You can turn on the radio station. That's a specific data attribute for each of the road trip. What is the route for that road trip? When do you start? When you finish? Whether you do any detour or not? Okay, or potty break. Sorry. Okay. Now let's take a look at the relationship here. Relationship. What is this? Either 0 or 1, right? Car. Either 0 or 1 car can have 0 or more road trip. That's what I will read this one. Okay. Yeah. Alright. So one question in Zoom chat: shouldn't get road trip be method under car? Get road trip. Which one? get road trip. I'm missing something or not? Get road trip. Do you mean this one? Okay. Let's read this one. Okay. In the example of both, the car class and the road trip class has interrelated, so it has some association. Okay. At one end of the line, the car takes on the associations of the assigned car. So one road trip, the car has been assigned to each of the road trip, okay, with the multiplicity value of 0 to 1. So when the instance of the road trip exists, it can either have one instance of car associated with it or no car associated with it. Okay, so that means one road trip can either have 0 or 1 car assigned. Okay, that's the thing. In this case, a separate caravan class with a multiplicity value of 0 to many, has 0 or more, is needed to demonstrate that a road trip could have multiple instances of cars associated with it, since one car instance could have multiple get road trip association. Yeah, one car can have multiple road trip, okay, association. In other words, one car could go on multiple road trips. The multiplicity value is said to be 0 or more. 0 or more. Okay, so one car can have 0 or more road trip. Yeah, that's the relationship here. But one road trip can belongs to either 0 or 1 car. That kind of thing. Okay. All right. Make sense, everyone? Yep. So next one, this one I already mentioned to you before, the multiplicity. One has one has many, many has one, many has many. Okay, there are different multiplicity, and normally we read from the left to the right. Okay, this is an example. Let's take a look at this one by one. One purchase history has exactly one customer. Yes, yeah. When you purchase something, it can belong to only one customer. Okay. One customer can write 0 or more product reviews. Yes, one customer can write 0 or more product review. I can write or I cannot write, or I can write multiple product reviews as well. Either one is fine. One order has one or more order line. Okay, one order can have one or more order line. Order line is like items. One order can have multiple order line. It could be avocado, milk, eggs, that kind of thing. Okay, but can we make an order without any order line? No, right? So one order must have at least one or more order line. Okay, 0 or more orders can have 0 or 1 gift wrapper, gift wrap paper. So whether I bought a product or not, right? I can also decide whether I want to have a gift wrapping or not. It really depends. Okay, let's say I buy a jar from David Jones. I can either have a gift wrapping or not gift wrapping at all. It really depends. Okay, does it make sense here? Okay, one has one has many, many has one, many has many. Okay. All right. Next, yeah. That's the bidirectional, okay, the relationship, the association between the two classes, left and the right. But now this is the unidirectional association, and for the unidirectional association, it consists of only 2 types. Okay, as I mentioned to you before, aggregation and the composition. Okay. First, the aggregation, it implies that a relationship where the child can exist independently of the parent. You need to understand what is a parent class and the child class. Okay, once you know it, then you need to define whether the relationship or whether the child class can exist independently or not. The difference between aggregation and the composition is just about independent. Okay, whether the child class can exist independently or not. If yes, aggregation. If not, then composition. Let's take a look at the example. Okay, teacher, which is a parent class, and the student is the child class. Okay, whether these two relationship is independent or independent. Okay, probably independent because once we don't have the teacher class, which is the parent class, can student exist on its own? Yes, you can exist, right? But let's think about the house and the room here. House is a parent class, the room is a child class. Can the room exist on its own? Probably no, because the room belongs to the house. The room cannot exist separately from the house. Does it make sense? Think about my body, okay? I have the head and the hands, okay? Head and hands, probably it should be the composition, right? Because I cannot survive, I cannot be alive without my hands and my hand, okay? So that means the heads and the hands belongs to the body, that kind of thing, okay? But what about the shirt? Okay, the shirt probably it can exist on its own. It is the aggregation relationship. Okay, the shirts. Okay. Let's take a look. A few more examples here. Oh, I forget to mention the notation as well. Yep. So aggregation, it has to be this symbol. Okay, this symbol. This is the aggregation. This is the composition. Okay. All right. The cars and the passengers. Cars can have or must have, may have or must have passengers. Only may, right? So that means passengers, the child class, can exist independently, okay, without having a cause. But can a car be driven without an engine or not? Probably no. So the engine belongs to the car. Okay, so that's why we need to use the composition here, okay, for to describe the relationship between the car and the engine. But for the car and the passengers, we will use the aggregation. Okay. Any questions so far? Is it clear to everyone or not? Surprisingly, this is one of the hardest concept ever for this unit, and the rest probably it will be easy. All right. So again, just want to emphasize again, aggregation. It is used to describe whether the child class. It used to describe that the child class can exist independently. Composition. It is used to describe that the child class cannot exist independently of the parent class. Okay. So take a look at the person here. As I mentioned to you before, this is a person as a parent class. We have the head, the hand, and the leg. Okay. The key question here is that whether the head, the hand, and the leg can exist on its own or not. Probably no. So that means here we need to use the composition, right? A person is composed of heads, hand, and legs, okay, of the person. Heads, hands, and leg cannot exist on its own. But if I have another class here, let's say shirt, S-H-I-R-T, okay, yep, and okay, and for here, I would say that it has to be aggregation, okay, because the shirt can exist on its own, right? All right, next, I'm gonna move to the next one now. Yep. This is the next one, generalization, okay? It is used to describe is a relationship. It's not the bidirectional, it's not the unidirectional, but this is another type of the relationship. It's called is a relationship, and or someone called inherited. A class inherit from the other class properties, that kind of thing. Okay, so inheritance, what does it mean? It is the process of a child or subclass taking the functionality of a parent or the superclass. It is also known as a generalization, and we use the arrow here to arrowhead here to describe the relationship, the is-a relationship. Okay, so normally we use for the abstraction, right? Let's say you have a car. We can abstract to the higher level as well, which is called vehicle. And one vehicle can have multiple we can have multiple types of the vehicle. It can be a car, motorcycle, bicycle, van, trucks, whatsoever, right? Let's take a look at the superclass or the parent class here. Parent class, that's name vehicle, okay? It has 3 types of the data attribute. Everything is described as the public modifiers, okay? We have the speed, the passengers, and the fuel type, okay? Speed, integer, okay? It is set as a 0 at the beginning. Passengers, it is described as an integer. It must have at least 1 passenger. And fuel type, it is described as a string, which can be diesel or whatsoever, okay? And the operation here, the vehicle can go, stop, or the change direction, right? And that's the superclass. The car class here inherit the common properties or that kind of thing, the data attribute here from the superclass. So that means the car can also have 3 data attribute here and the 3 extra data attribute here as well, which include the model type, the doors, automaker, and the radio, windshield wiper, and the change direction. Okay, make sense? Yeah. So we use the closed arrowhead pointing towards the superclass to describe the is-a relationship. Yep. Next, is-a relationship. This is a few more examples as well. Every lecturer and every tutor have name, ID, password, and both of them can inherit from the user class here, right? So how to draw this one? We have the user class, okay, user, all right, and inherit, okay, yep, and we have lecturer here, okay, and the tutor here, inherit the common properties, okay, the name, okay, name, ID, password, that kind of thing, okay, from the user class. Lecturers and tutors can mark assignment because users can, because both of them can do the mark assignment. So probably I will put it here, mark, okay, assignment. Subclasses provide extra operations and the attribute. Lecturers can create assignment, okay, so I will put it here, create assignment, CA, okay, create assignment. Subclass can override operations of its superclass as well, so we will show this later. So that means instead of mark, maybe I can do something like submit, remark the whole assessment, that kind of thing. I can do that as well. Yep. My goodness, why I draw in the previous one, okay. It has here. So as I mentioned to you before, the user, that's a superclass. It has name, ID, password. It can log in, mark assignment, whatsoever. The tutor can flag assignment for remark as well. Lecturer can create the assignment, that kind of thing. That's the class diagram from the previous description, okay. And what is this? I think we can skip. Okay, class diagram. Let's take a look at this one, which is a little bit more complex. Okay, anyone remember what is this one? Okay, can you type in the Zoom chat? What is this? Composition. Thank you. That's right. Okay. So in this class diagram, we have 1, 2, 3, 4, 5, 6, 7. We have 7 classes. Okay, 7 class, and we're gonna. The purpose of drawing the class diagram is to describe the relationship between the classes, and then we're gonna look at it one by one. Okay. Maybe start with the user because everything point towards the user. User is the superclass. The customer inherit the common properties of the user class admin also inherit the common properties of the user class. There's a generalization relationship or the is-a relationship. Okay, customer admin inherit the user properties. It has these 4 common data attribute. This is a 2 extra for the administrator class. This is a extra data attribute for the customer. Okay, and they can do more as well. Okay, sure. Customer. What is this? Customer and the shopping cart, right? Shopping cart, we read the description from the left to the right. One shopping cart, okay? 0 or more shopping cart will have no, this is not the bidirectional, sorry. This is the, what is that? The composition. So that means one customer, how to read this one? One customer can have 0 or more shopping cart, right? So then we need to think about whether the shopping cart can exist on its own or not. Yes, probably yes, right? So that's why we use the composite. No, sorry. The shopping cart cannot exist on its own because when they want to buy something, there must be the name of the customer. Otherwise, it will be a ghost, right? So the shopping cart cannot exist on its own. That's why we need to use the composition relationship here to describe, okay, the relationship between the customer and the shopping cart. The customer can have multiple orders as well, 0 or more orders. That's the composition relationship as well, because when customer want to order something, it must be the order cannot exist on its own. Okay, so that's why we need to use the composition relationship. What about for each of the order? Okay, for each of the order, will have the shipping information, which is a one-to-one relationship anyway. One order, one shipping information, right? Okay, and each of the order also has one order detail as well. Okay, so it can be the order ID, the product ID, the product name, quantity, how many of them, unit cost, subtotal, and the calculate price, the total price, that kind of thing. All right, make sense here? That's the an examples of the online shopping. Yeah, composition. Yeah. Can the shopping cart have 2 or more customer? Probably unlikely, right? I have never seen that. Whether one shopping cart can have 2 or more customer. Yeah. When you establish an order, one shopping cart, right? And only you, one customer. Okay, next. This is probably the last one, the last diagram of today, sequence diagram. Okay, sequence diagram is a type of the interaction diagram because it describes how and in what order a group of objects work together in a sequence in a time order. Okay, and these diagrams are used by software developers and business professionals to understand the requirement for a new system to document the existing process as well. For example, like in your case, you need to develop an online shopping system, Monash, merchant, whatsoever. You need to draw the sequence how 2 or more objects interact with each other, the customer, the ecosystem, that kind of thing, you know? How do they interact with each other? So we need to draw the sequence diagram as a common understanding among the team. All right. And before we move on to the diagrams, we need to understand the symbol and the notation, which is very important. Okay. First, the square here is the object symbol. You have the activation box. You have the actor. We use the human like this, okay, to then demonstrate the actor symbol. Package, the lifeline, the option loop symbol. The sequence diagram can have a loop as well, okay? Loop. What is the condition? If, else, that kind of thing. Yeah, and the alternative, this is more like if, else, okay? Loop, think about the while loop or for loop. Why true something, you need to have the condition. Why, whether the condition is true or not, and then do the loop, that kind of thing, okay? Alternative, this is the if else condition. if condition something is true, we do like this, else like this. For example, what would be the good condition here? If the payment is successful, the flow will be like this. If the payment is not successful, it will be another flow. Okay. The solid line with the closed arrowhead, this one, it is used to describe the synchronous message symbol. When each of the flow, each of the event, you can have the message respond back to the actor as well. That's the open arrowhead is the asynchronous message symbol. Dash line arrowhead like this. It is used to describe the reply message symbol. Okay, let's take a look at this example. This is the ATM system. Okay, it looks very complex, but in general, what you have seen, try to read this one together. First, you have an actor. Okay, and what is this one? What is this one? The square. The square. The square used to describe the object symbol. This is the object. We have the ATM object, we have the bank server object, we have the bank account. Think about the ATM system. Okay, that's the object. Lifeline. Okay, the next one. Lifeline symbol, the activation box. Okay, this is the lifeline. Okay, lifeline. Here you have 4 lifeline. Okay, and this is the activation box. Okay, I'm not going to draw that long to make sure that it's not complicated. Yep. And this is the if else, the alternative. Okay, alternative. As I mentioned to you before. Okay. Yep. This one, it doesn't have the loop. All right. Only the alternative condition and the else alternative symbol. Okay. And now next one is a synchronous and the asynchronous message. Right. So maybe I will clear my screen a little bit. Okay. The first event, the flow. Okay, the flow of events. The first step is that a person need to insert the ATM card. Okay, and it goes to the activation box here. Okay, ATM will verify the card with the bank server, and then it goes to the condition now whether the card is valid or invalid. Okay, if the card is valid, we use the dash line to describe here the card is okay. Okay, what is the dash line? Reply back message. Is that right? Reply message. Okay, from the bank server. When you have the clear my screen a little bit. Okay, we use this row synchronous message symbol. Okay, to represent the verified card here. Okay, ATM will send a message to the bank server to verify the card. Reply back message. Okay, the card is okay. Then the ATM will request a PIN. Okay, from the user, from the customer here. All right. If the card is invalid, then it will return a message. What is that? The card is invalid, and then the ATM will eject the card. Okay. But if the card is valid, it will move to the next step, right? Okay, the next step. So the ATM will ask the customer to enter the PIN number, the 4 digits PIN number. Okay, and we use the reply message here. Okay, as a interaction as a response after this one. Okay, then the ATM will verify the PIN number with the bank server. Then we need to check whether the PIN is valid or not. If the PIN is okay, that's a reply message. Okay, then ATM will ask, okay, prompt a message, request an amount. Okay, how much do you want to withdraw? That kind of thing. But if the PIN is invalid, then the card will be ejected. Okay, the ATM will eject the card. If the PIN is okay, it will request the amount. Then the person has to enter the amount to the ATM, and then the ATM will start the transaction by checking with the bank account whether it has sufficient funds or not. If the funds are sufficient, then reply back the message, funds okay, to the bank server, and then the bank server can send a message to the bank account to withdraw the amount. Okay, if the withdraw amount is successful, the withdrawal request is successful, that's a response message. Then the bank server will send a message to the ATM, right? That, hey, look, the transaction is successful. Then the ATM can dispense the cash to the customer. But if the funds are insufficient here, then the bank account will send a message to the bank server that the funds are insufficient, and then the bank server will send a message to the ATM that, hey, look, the transaction is unsuccessful. That's why later on, ATM will eject the card to the customer. Okay. Can we use reply arrow between the ATM and the person? I didn't get the difference between reply and solid one. Okay. I would say that solid one is like a request, like a prompt message for input something, and then dash line is a response. Okay. But let's take a look at your question again. Can we use the reply arrow between the ATM and the person? Let me take a look. ATM and the person. Okay. ATM. It depends on which direction, I would say. Okay. It depends on the direction. Let me clear the screen again. I'll try to see an example. Let's say the ATM send a message to eject the card, right? No, probably not. That is not a good example. ATM, we use the solid line here as a synchronous message. That means it requests a reply back from someone, from the actor here. So that's why this is the reply, the response from this request. Okay, does it make sense? That's why we use the dash line. Yeah, and then we request a prompt from the bank server as well, whether the PIN is verified or not. That's why the bank server will use a reply message. This is the reply from this request. Okay, that the PIN is okay, that kind of thing. Okay, yep. Okay, thank you. Could you provide an example of asynchronous message? Asynchronous message. That's a good question. I cannot come up with an asynchronous message live at the moment. But let me think. Yeah, so asynchronous don't require a response before the sender continue. It don't require a response, right? But synchronous require a response. So that's the difference. If no response, let me think. Asynchronous symbol for the ATM. I don't know. I cannot come up with a live example for now. But if I come up with something, maybe I will explain later as well. Okay. This is just a more explanation of that figure, so I'm gonna skip. Alright. Oh, somehow I complete all of the lecture slide. Okay. Any questions? Yeah. Any questions so far around the use case diagram, use case scenarios, object oriented, OOP, class diagram, and the sequence diagram? But because you asked and we still have time, I'm gonna Google and try to sequence diagram with synchronous message. Let me see if I can find some good example and I can explain to you. Okay. Maybe this one. What do you think? Can a sync message have an async message as a response instead of a reply message? What is this one? Export declaration. We have a company user. First, click export declaration. Probably there's a button, and then it shows the view declaration. Blah 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 blah. Too complicated. Let me find a better example. Maybe this one. Place order. Yeah, this is good. Okay. Yeah. But again, it doesn't have the asynchronous. No. No. It doesn't have one. This is the asynchronous. Yep. Asynchronous. Probably if I go back to the ATM, okay, what I would do instead of insert the card to have the asynchronous message, right? Maybe I can put it here. Shape, arrow. Where is that? Can I find something? Chart. No. Okay, Google presentation slide is not designed for the sequence diagram. Maybe I'll just draw by hand. The difference between synchronous and the asynchronous message is whether the response is required or not. When we use the solid line with the closed arrowhead, that's the synchronous message. It requires a response back. But if not, it can be like this, right? First, person interact with the ATM, and then ATM insert the card. Maybe what I want to say here is that a synchronous message can be like hello, you know, hello, like hello. It does not require the response back from the ATM, you know. The first step is hello, and then once they insert the card, there's a close arrow, okay, verify, blah blah blah, whatsoever, eject the card, and then the eject card yeah. Can eject card be asynchronous? Good question. I would say no. Okay. What I mean is that when you eject the card, you request the person to take the card back. Okay. So you want some response from the actor here as well, right? But when you use the asynchronous here, okay, sorry, not the, like, let's say hello, like this, okay, hello, then you don't require the response, that kind of thing. So rather eject the card, I would say, if you want to have another asynchronous message, you can say thank you. Okay, thank you. Does it make sense to everyone? When you say hello, thank you, you don't require a response unless you are so polite, right? Then you say you're welcome, but it's a little bit weird. You don't need to say you're welcome to the ATM system, so you know. Okay, all right, cool. Any other questions in addition to the synchronous and the asynchronous symbols? If not, then maybe I would finish the lecture today. Luckily today we don't have the flux quiz, okay, but we're gonna have it next week. And then that's all. Thank you so much everyone for your attention. I will see you all in the afternoon. Yeah, bye bye.